Hello, friend. Welcome to Science for Sleep. Tonight, we begin with something so familiar that it can almost disappear into the background of life. The stars above us. Small points of light that have watched over sleeping fields, quiet oceans, empty roads, rooftops, deserts, forests, and cities for longer than any person could possibly imagine. For most of human history, they were not a special event, not an occasional trip out into nature, not something people had to go searching for. They were simply there, rising into view as the day faded, becoming part of what night felt like. And yet the stars are stranger, gentler, and more powerful than they first appear. On a truly dark night, the human eye can see thousands of stars spread across the whole sky, though never all at once, because half the sky is always hidden below the horizon. From one place on Earth, only a portion of that great field is visible at any moment. In modern cities, that number can fall dramatically. For many people, the night sky now offers only a few dozen stars, where earlier humans would have seen far, far more. The sky did not grow emptier. Our world simply grew brighter beneath it. Light rose from streets, windows, signs, parking lots, and buildings. And in doing so, it covered over one of the oldest sights human beings have ever known. There is another quiet surprise in that. When you first step outside at night, you are not seeing the full sky yet. Your eyes are still adjusting. The daytime system in the eye gives way slowly to the nighttime one, and over the next 20 or 30 minutes, the dark begins to reveal what was already there. More stars appear. Faint haze sharpens into structure. What first looked like emptiness becomes presence. What first seemed like a mostly blank sky begins to fill with depth. In a very real way, the stars do not rush toward us. We learn how to see them. This makes the night sky feel almost patient. It does not force itself on the eye. It waits. A person steps outside, stands still, breathes a little more slowly, and the sky begins to answer that stillness by offering more of itself. A brighter star appears near the edge of vision, then another, then a faint cluster, then a pale band that did not seem visible at all a few minutes earlier. The darkness is not changing very much in those moments. The person is. If you enjoy these quiet journeys, you're welcome to subscribe, and if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. Long ago, under skies untouched by streetlights, the Milky Way was not a rare sight or a photograph on a screen. It was part of the ordinary night. A pale river of distant starlight stretched across the darkness, bright enough to shape how people felt about evening itself. It turned the sky into a landscape. It gave depth to darkness. It reminded anyone looking up that night was not empty at all, but filled with structure, distance, and quiet light. In some places, it would have been so clear and so steady that it must have felt less like decoration and more like part of the world itself, as natural and expected as hills, rivers, wind, and weather. That alone may help explain why so many people feel something soften inside them when they look at stars. Modern research suggests that starry skies can create feelings of awe, calm, and mental quiet, in a surprisingly short amount of time. Vastness has a way of gently shrinking the noise of the day. The eyes stop moving from object to object. Thought slows. Attention widens. For a moment, the human mind is no longer trapped in the small, repeating circle of tasks, worries, plans, and unfinished things. It is simply looking, and perhaps that is part of the comfort. The stars do not ask anything from us. They do not need a response. They do not hurry. They do not compete for attention in the way modern life so often does. They remain where they are, quiet and distant, and yet they still manage to change the feeling of a moment. A roof becomes a place of pause. A yard becomes a place of stillness. A road at night becomes something softer, less closed in, less crowded by thought. That may be one reason the stars have stayed so close to human life for so long. Not because we could reach them, but because we could live beneath them, sleep beneath them, travel by them, mark seasons by them, tell stories through them, rest under their steady presence while the world below grew cool and still. The stars were never only distant objects. They were also part of the background rhythm of human evenings, part of the feeling of night arriving and the body slowly easing away from the brightness and labor of the day. So tonight, that is where we begin. Not with distant explosions or technical charts, but with a human being standing under a dark sky, waiting just long enough for the stars to appear in full. Because the stars are not only objects in space, they are part of how human beings have experienced night itself. And once the darkness settles in, the body begins to understand that change as well. The first few stars often seem simple. A handful of pale points resting in the dark, easy to notice and easy to take for granted. But the night sky does not usually reveal itself all at once. It arrives in layers. What looks sparse at first can become rich and crowded a little later, even if the sky above has not changed at all. That quiet change is happening inside the eyes. Human vision uses two different systems. In bright daylight, the eyes rely mostly on cones. These are the cells that help us see fine detail and color. They work well in sunlight, under lamps, and in all the bright conditions that fill most of a normal day. But cones are not very helpful in deep darkness. As evening settles and the available light drops, the eyes slowly begin handing more of the work over to rods instead. Rods are much better at detecting faint light, which is why they matter so much under a starry sky. The trade-off is that rods do not give us rich color. They are sensitive, but they are not very expressive. That is one reason stars often appear white, silver, or only faintly tinted to human eyes at night, even when cameras later reveal much stronger color. This shift does not happen instantly. It takes time. In darkness, the retina begins building up a light-sensitive chemical called rhodopsin, sometimes called visual purple. As more of it becomes available, the rods grow more useful, and the eye becomes far better at detecting faint starlight. This is why the sky can seem to open gradually over 20 to 40 minutes. A star that was invisible at first may become obvious later. A faint patch near the horizon may separate into several individual lights. A soft haze overhead may begin to feel like structure instead of emptiness. The darkness itself has not deepened very much in that short time. The eye has simply become more prepared to meet it. There is something very calm about that process. Night vision does not arrive like a switch being flipped. It gathers. The world of sharp daylight detail fades back, and another kind of seeing begins to take its place. Edges soften. Contrast matters more. Tiny, distant lights begin to stand out. The sky becomes less like a ceiling and more like a field extending away from the body in all directions. That is also why a person may feel that stars are appearing out of nowhere when they stand outside long enough. It can feel as though the sky is becoming busier by the minute. But in truth, many of those stars were already there from the beginning. The eye simply was not ready for them yet. Night asks for patience, and the body answers slowly. There is another small and useful detail hidden in that. The center of human vision is not always the best place to detect the faintest light. When something is dim enough, it can actually become easier to see by looking slightly to the side of it instead of directly at it. This is called averted vision. The outer parts of vision are often better at picking up very faint light because rods are more useful there. So a dim star or a soft patch in the Milky Way may seem to strengthen when the eye relaxes and looks just off to one side. Astronomers use this on purpose, but ordinary people do it too without realizing it. A faint star at the edge of sight can suddenly feel clearer than one stared at too directly. This means the night sky is not only something we observe, it is something we learn moment by moment through the body's own adjustments. The eye becomes quieter, more sensitive, less interested in color, less interested in sharp daytime detail, and more able to work with softness and low light. The stars begin to emerge through that change, and once they do, they rarely hold perfectly still. The tiny points that seem so calm at first begin to flicker, tremble, and shimmer in the dark air. A star low above the horizon may appear to flash more sharply than one overhead. Another may seem to brighten, then soften, then brighten again, as though it were breathing very lightly through the night. What changes in those moments is usually not the star itself. It is the air between the star and the eye. Starlight travels across immense distance with remarkable steadiness, but its final passage is through Earth's atmosphere, and the atmosphere is never completely still. It is made of moving layers, pockets of warmer and cooler air, slight differences in density, and gentle currents that bend light by tiny amounts as it passes through. By the time that light reaches the eye, it has been nudged and shifted again and again. The result is what people call twinkling. A star's brightness seems to jump, its color may briefly change, and its position can appear to quiver, even though the star itself remains far away and calm beyond the air above us. That means the twinkling of stars is, in a very quiet sense, one of the most familiar ways people see the atmosphere without realizing it. The sky may look empty between the body and the stars, but it is not empty at all. It is active, layered, restless, and always in motion. On some nights that movement is subtle, making the stars shimmer softly. On others, especially when the air is more disturbed, the flicker becomes stronger, more obvious, almost playful. A bright star can flash with surprising intensity, then settle again a moment later. This is also why the night sky can feel more alive than a photograph. A photograph freezes the stars into still points, but the real sky is always moving in small ways. A person standing outside on a cool evening may notice that no star seems to hold exactly one shape for very long. Even the calmest sky has a slight uncertainty in it, a softness of motion that belongs not to the stars alone, but to the air close to home. Not every bright object in the sky behaves this way equally. Planets often twinkle less than stars. To the eye, they may look like stars at first, but they tend to shine more steadily. The reason is simple. A star is so distant that it appears almost like a single tiny point of light. So even small disturbances in the air can change how it looks. A planet, by contrast, presents a slightly broader disk of light. The atmosphere still affects it, but the effect is spread across a larger apparent shape, so the flickering is often gentler. There is another reason some stars seem more unsettled than others. The lower a star sits in the sky, the more atmosphere its light must cross before reaching the eye. A star high overhead sends its light through a shorter path of air. A star near the horizon sends it through much more. That longer passage gives the atmosphere more chances to bend, scatter, and soften what the eye receives. So stars near the horizon often twinkle more strongly, and they also tend to look dimmer and redder than they do when higher in the sky. This is why the first bright star noticed near evening can sometimes look warmer in color than expected, or less steady than a later star seen higher overhead. It is not only the fading light of dusk, it is the thickness of air between the ground and that low point of brightness. Dust and air molecules scatter shorter blue wavelengths more easily, allowing redder tones to show through more strongly when the light has traveled a longer atmospheric path. The same sky that reveals the stars is also quietly changing their appearance. On cold, dry nights, many people feel that stars look sharper, cleaner, and somehow more exact. That impression is often correct. When the air holds less moisture and fewer particles, there is less scattering and absorption. With steadier air, bright stars can appear crisper and more settled, as though the sky has been gently polished. The stars have not moved closer. The atmosphere has simply become a clearer window. So even in stillness, the night sky is never truly motionless. It wavers through air, deepens through darkness, and reaches the eye through a final layer of restless planet-bound weather. What looks distant is always being shaped by something very near. And beyond that flicker, there remains another quiet surprise. Even on the darkest nights, the sky itself is not perfectly black. The sky can feel sparse or overflowing depending on where you stand. On one night, a person may step outside and notice only a few familiar points above the rooftops. On another, far from streetlights and glowing windows, the same sky can seem crowded with light, as though the darkness itself has been filled with quiet detail. The difference can be so dramatic that it almost feels like two different worlds. But the stars themselves have not changed. What changes is how much of them reaches the eye. Even under excellent conditions, no one ever sees the whole star-filled sky at once. Half of the sky is always hidden below the horizon, and the human eye can only detect the brighter fraction of the stars that fill our galaxy. Across the full celestial sphere, a few thousand stars are bright enough to be visible to ordinary human vision. But from one place on Earth, only a portion of that number can be seen at any given moment. Even on a very clear night in deep darkness, the visible sky is still only part of a much larger field extending all around the planet. That alone makes the visible night sky feel a little more precious. Every evening offers only one section of the greater whole, one curved half of a much wider star field. The stars that rise over a person in one season are not the same arrangement that will appear months later. Some remain hidden below the horizon from certain latitudes. Others belong to the southern half of the sky and never appear for people living far north. The sky always gives a partial view, never the full inventory all at once. And yet, even that partial view has become much smaller for many people in the modern world. In places where artificial lighting is strong, the eye may only find a few dozen stars. The brightest ones still break through. A planet may hang above a neighborhood. A constellation may survive in fragments. But the thinner stars, the faint field behind the obvious lights, and the soft structures of the deeper sky are often lost inside a pale, urban glow. By contrast, in dark rural areas, hundreds and then thousands of stars return, and the sky begins to recover its depth. The difference is not subtle. It is the difference between a mostly empty ceiling and a vast distance filled with light. This is also where many people first understand what the Milky Way really looks like to human eyes. In photographs, it often appears bright, richly colored, and almost cloud-like, with bold blues and golds stretching from horizon to horizon. But that is not how it usually appears in direct human vision. To the eye, the Milky Way is far gentler. It looks like a faint band, a long pale wash of light, almost grey, sometimes slightly greenish, broad and quiet, rather than dramatic. It is made of countless distant stars blending together into something the eye can sense more as texture than as detail. Under darker skies, this soft band gains more shape. It stops feeling like a vague smear and begins to show unevenness. Some areas seem richer, others seem thinner, and in very dark places, something even more striking becomes visible within it. Long dark gaps and branching shadows cutting through the glow. These are the dust lanes of the Milky Way, colder bands of interstellar dust lying between us and the denser star fields behind them. They do not shine. They interrupt. They turn the bright river of the galaxy into something layered, with depth and silence inside it. That is one of the quietest losses caused by bright modern nights. Light pollution does not remove stars from space. It removes contrast from human seeing. The faint stars remain above the cities. The Milky Way still arches over highways, apartment towers, parking lots, and suburbs. The dark lanes are still there. The deeper field is still there. Much of the sky is simply hidden behind brightness rising from the ground. Dark Sky International notes that as people move away from artificial light, the sky does not become newly populated. Rather, a veil recedes, and what was always present becomes visible again. So the true difference between a sparse sky and an overflowing one is not the number of stars above the Earth. It is the amount of darkness between the Earth and the eye. And that darkness does more than reveal distant light. It also begins working quietly on the body below, guiding it toward a different state altogether. The night sky is not only something we see. It is part of a larger transition the body understands. Long before anyone knew the word melatonin, long before clocks, lamps, and glowing screens. The human body was already responding to the same pattern it still responds to now. Light fades. Contrast softens. The sky darkens. The stars begin to appear. And somewhere within the body, a quieter process begins as well. Darkness helps signal that the active part of the day is ending. As evening arrives and light levels fall, the brain begins to increase production of melatonin, a hormone closely tied to the sleep-wake cycle. Melatonin does not force sleep in some sudden dramatic way. It works more gently than that. It helps prepare the body for rest, nudging it away from the alertness of the day and toward the slower chemistry of night. Under natural conditions, this rise begins in darkness and continues through the night, peaking toward the early morning hours before daylight begins turning the body back toward wakefulness. That means night is not simply the absence of day. It is an active change in bodily state. The dimming sky outside and the changing chemistry inside belong to the same rhythm. When the sun drops and the world loses brightness, the body is not passively waiting for sleep. It is already beginning to reorganize itself around the new conditions. Heart rate can ease downward. Muscles may feel a little heavier. Thought may lose some of its sharp daytime edge. The body becomes less oriented toward action and more prepared for stillness. For most of human history, this process would have unfolded with far less interference than it does now. Without strong artificial lighting, dusk carried more authority. Evening arrived not only visually, but physically. The shadows lengthened, and there was little to push back against them. Firelight and moonlight could soften the darkness, but they did not erase it. The body still understood what was happening. Night was coming, and with it came a different kind of time. That older transition was probably more gradual and more complete than what many people experience now. A modern room can remain bright long after sunset. Streets, devices, signs, and indoor lighting can keep the eyes and brain exposed to signals that resemble extended daytime. But in a more natural setting, the change from day to night would have been easier to feel. The bright detail of afternoon would give way to the lower contrast of evening. Work would become harder. Distances would become softer. The eye would stop relying on color and begin leaning on shape and shadow. And at the same time, the body would begin yielding to drowsiness with less resistance. This makes darkness feel less like emptiness and more like instruction. It tells the body what kind of hours have begun. The stars fit naturally into that larger process. They do not cause melatonin, and they are not themselves the switch that changes the body. But they are part of the environment that becomes visible only when darkness has reached a certain depth. In that sense, they belong to the same transition. A person notices the first stars at almost the same part of the evening, when the body is beginning to quiet itself. The mind may still be active, thought still moving, but the wider world has already begun simplifying. The sky loses its blue. The ground cools. Sounds often grow more separate and more distinct. The body is still awake, but less firmly attached to the pace of the day. There is something deeply familiar in that change, even now. Many people know the feeling without needing to explain it. The same room can feel different at night than it did in the afternoon. The same yard, road, or window can carry a softer atmosphere once evening has settled in. Food, conversation, and movement begin to feel different as brightness drains away. The world itself has not become less real. It has simply become less demanding. And that may be one reason the stars feel so naturally connected to rest. They appear when the world begins asking less of the eyes. They belong to an hour when detail thins out, and the body no longer needs to stay fully prepared for action. Their presence is gentle, distant, and quiet. They do not brighten the world enough to wake it back up. They simply accompany the darkening. But darkness is not always complete. Sometimes the sky remains touched by another kind of light, softer than daylight, but strong enough to reshape the night in its own way. Not every night was equally dark, and human life once changed with that difference. A night lit only by stars feels very different from a night lifted by a bright moon. The stars can fill the sky, but they do not usually brighten the ground very much. Moonlight does. It lays a pale wash over fields, paths, water, rooftops, and open land. It softens edges instead of erasing them. It gives just enough light for the world to remain partly visible after sunset. And for much of human history, that difference mattered. Starlight alone is delicate. It gives the sky depth, but it leaves the earth mostly in shadow. Moonlight changes the balance. It can turn a dark hillside into a visible slope, a path into something readable, and a gathering place into somewhere people can still remain after dusk. That made certain evenings longer in a practical sense. A full or nearly full moon did not create daylight, but it gave people more usable time. It made walking easier, made faces easier to read, and made movement after sunset less uncertain. Some sleep studies suggest that the human body still responds to that older pattern. On the nights leading up to a full moon, when moonlight stays in the sky longer after dusk, people often fall asleep a little later, and sometimes sleep a little less. In both rural and urban groups, sleep has been observed shifting later by roughly 30 to 90 minutes near fuller moon phases. The likely explanation is not that the moon has some mysterious force over sleep, but something simpler and older. Bright moonlight once extended the evening in a useful way, and human behavior may still carry a faint echo of that rhythm. That makes moonlit nights feel less like an interruption and more like a second kind of evening. Darkness still arrives, but it arrives in degrees. Some nights become deep quickly, the ground disappearing while the stars sharpen overhead. Other nights stay suspended in a softer state, with silver light lingering across the landscape. Under those brighter skies, older human activities could stretch a little farther into the night. People could talk longer, travel a little farther, check animals, gather outdoors, fish, hunt, or simply remain awake in company, without feeling that the usable world had fully closed. Moonlit nights allowed more movement and more social life after sundown, because the light itself changed what the evening permitted. That also means human time once had more texture than the simple division of day and night. There was daylight, of course, but there was also twilight, starlight, and moonlight, each with its own feel and its own limits. A moonless night would draw the world inward more quickly. A bright moon would hold it open a little longer. The body would still recognize darkness, but it would do so within a more varied natural pattern than many people know now. Evening was not always one thing. It could deepen gently, or it could remain lifted for hours by reflected sunlight from the moon. This contrast matters for the stars as well. On brighter moonlit nights, the sky often loses some of its finer detail. Fainter stars fade first. The darker parts of the Milky Way become harder to make out. The heavens remain visible but less rich. On deeper, moonless nights, the opposite happens. The ground disappears more completely, but the sky gains density. More stars emerge. The Milky Way strengthens. Dark lanes become easier to notice. So one kind of night gives more to the earth below, while the other gives more to the sky above. Neither is more natural than the other. Both belong to the older shape of human evenings. One helped people remain active a little longer. The other drew them more fully into darkness, stillness, and upward attention. Together, they formed a cycle within the wider cycle of night itself. And when there were no streetlights, no glowing windows, and no electric haze rising from the ground, even the darkest nights would have offered a sky far fuller than most people today have ever seen. For most humans who ever lived, the night sky was fuller than most people today have seen. Not fuller because there were more stars then, but fuller because less stood in the way of them. There were no glowing suburbs at the edge of vision, no light rising from highways, stadiums, office towers, storefronts, apartment buildings, or parking lots. Once the sun was gone and the moon was absent or low, darkness could spread almost without interruption from one horizon to the other. And in that darkness, the sky would have offered itself with a richness that is now rare. It is easy to underestimate what that would have meant in ordinary life. A truly dark night is not just a darker version of a modern one. It is a different visual world. The Milky Way would not have been a faint rumor visible only on special trips. It would have been a regular feature, a broad band stretched across the sky, pale and textured and unmistakable. Meteor streaks would have crossed overhead often enough to feel like part of the natural world, rather than a lucky event. Dense star fields would have filled spaces that now appear nearly empty. The sky would have felt inhabited. And because this was normal, people would not have treated it as an occasional spectacle. It would have been part of the environment in the same way hills, rivers, wind, heat, and cold were part of the environment. A person walking home after dusk, watching animals, resting near a fire, crossing open land, or lying awake outside, would have known the stars not as a special subject, but as part of the visible structure of night. The eye would lift and find patterns almost automatically. A brighter cluster over there, a faint river of light overhead, a familiar bright star lower in the west than it had been a season ago. That kind of sky changes the feeling of distance. A modern urban night often feels shallow. The ground is bright, but the sky seems flat. Under older dark skies, the opposite would have been true. The earth might fall away into shadow, while the heavens opened upward with tremendous depth. A person could look into darkness and find that the darkness was filled, not blank. This is part of what made the stars so useful to memory and orientation. The sky was not just above. It was detailed enough to become familiar. It also likely shaped emotion in ways people rarely had to explain. Wide star fields have a way of making the individual feel smaller, without making them feel unimportant. The sky becomes vast, but not hostile. It is spacious, layered, and quietly ordered. A person under that kind of night would have felt the size of the world more directly than many people do now. Not through numbers or astronomy, but through repeated exposure to an overhead distance that never seemed to end. This is one reason the stars appear so often in human thought, ritual, and story. They were not hidden behind glass or light haze most of the time. They were present, and presence matters. The important thing is not to imagine ancient dark skies as some unreal magical place. They were real, lived conditions. People worked under them, worried under them, traveled under them, loved under them, and slept under them. The stars did not remove hardship, and they were not always comforting. But they were constant enough to become woven into ordinary life. A child learning the world would have learned the night sky as part of that world. An elder remembering seasons would have remembered where certain stars belonged. A traveler would have trusted familiar lights above the horizon. A community would have watched certain bright groups rise and return as part of the shape of the year. So when we say earlier humans lived under fuller skies, what that really means is that the sky itself held more practical and emotional weight. It gave more light to memory, more structure to night, and more visible continuity from one evening to the next. And once a sky is full enough to become familiar, the human eye and brain rarely leave it scattered for long. Bright points begin to gather, shapes begin to form. The stars become something more than lights. They begin to become figures. The sky is scattered, but the human brain dislikes leaving bright points unconnected. A person can look upward and see hundreds of separate lights, each divided from the next by darkness, and yet almost immediately the eye begins gathering them into something more organized. A line seems to form between one bright star and another. A curve appears. A cluster begins to feel like a group instead of a random collection. Before there is myth, before there is astronomy, before there is even a name, there is this first quiet act of perception. The human eye sees the stars, and the human brain begins to arrange them. This happens because people are very good at finding order, even when the order is only partly there. Bright things that sit close together tend to feel connected. A few stars standing apart from a wider field begin to look like they belong to one another. The darkness between them does not erase that feeling. In some ways, it strengthens it. The empty space becomes a kind of backdrop, allowing the brighter pattern to stand out more clearly. The sky remains full of separate points, but the brain prefers shape to scattering. That means constellations begin long before they become stories. They begin with simple visual grouping. One bright line of stars may feel more noticeable than a dozen dim ones around it. A compact cluster may catch the eye before a wider field does. The brain is always deciding what belongs together and what can be ignored, and it does this in the night sky the same way it does elsewhere in life. A few stars near each other begin to feel like one thing. A looser spread begins to disappear back into the background. Without needing to think about it, a person starts picking structure out of distance. This also helps explain why so many cultures, even when separated by oceans and centuries, notice some of the same star patterns. It was not because all people were told the same story. It was because certain groups of stars are simply very good at catching the eye. A line of 3 bright stars will attract attention almost anywhere on Earth. A tight cluster of bright points will do the same. A curved arrangement or a cross shape will feel memorable because it is already close to a form the brain knows how to hold on to. Different people may imagine different meanings, but they often begin from the same visible anchor. There is something deeply human in that. The sky does not come with lines drawn on it. It does not label its own shapes. And yet people continue to look upward and find figures, paths, tools, animals, families, hunters, sisters, birds, boats and rivers. This is not foolishness. It is one of the most natural things the human brain does. It takes what is large and scattered and turns part of it into something familiar enough to remember. That act of remembering matters. A sky full of separate lights is beautiful, but harder to keep in memory. A sky with shapes becomes easier to carry from one night to the next. A person who learns one grouping can find it again. Once found again, it becomes steady. And once steady, it can be used. It can help with direction, season, timing, and story. This is part of why the stars mattered so much to human life for so long. The patterns made them easier to return to. Instead of thousands of unconnected points, the sky became a set of familiar markers. The shapes also give a sense of calm structure to the darkness. The night remains wide and immense, but it no longer feels entirely scattered. A person can look up and find something known inside something vast. One pattern appears, then another nearby. The sky begins to feel less overwhelming and more legible. It still stretches beyond the eye's ability to count, but parts of it become recognizable. That is often enough. Human beings do not need to master the whole sky at once. They only need a few stable forms to begin building relationship with it. And once those forms are noticed often enough, they rarely stay as shapes alone. A line becomes a belt. A cluster becomes sisters. A cross becomes a guide. The stars pass from perception into memory, and from memory into story. A pattern becomes easier to remember once it becomes a figure, a family, or a path. A few bright stars may first catch the eye as simple shapes, but once those shapes are named, they begin to stay in the mind more easily. The sky becomes less like a scattered field and more like a place filled with recognizable forms. One group of stars becomes a hunter, another becomes a cluster of sisters, another becomes a cross rising over the darker half of the world. In this way, the night sky begins to feel familiar, not because it grows smaller, but because human beings find ways to carry parts of it with them. One of the clearest examples is Orion. Even people who know very little about the sky often recognize it once it is pointed out. The shape is strong and easy to hold on to. 3 bright stars in a row form the belt, and around them stand brighter stars that suggest shoulders, knees, or the wider outline of a figure. Because the pattern is so noticeable, many cultures gave it importance. In Greek tradition, Orion became a hunter. In other traditions, the same bright arrangement became a different kind of figure, but the central impression remained similar. The stars were vivid enough and arranged clearly enough that people continued to return to them. The Pleiades work differently. They are not spread out in a large shape, but gathered tightly together in one small part of the sky. To the eye, they appear as a compact cluster, like a handful of faint lights resting close together. Many people can see 6 of them easily, while others may notice more under very dark conditions. Because they feel like a group so immediately, they have often been imagined as sisters, maidens, or a family of some kind. The details changed from culture to culture, but the sense of togetherness remained. The eye meets them and almost instantly understands that they belong together. Then there is the Southern Cross, one of the most recognizable patterns in the southern sky. Its stars do not need much imagination to feel connected. The shape is firm, simple, and memorable. That clarity helped make it useful. It could be remembered easily, located quickly, and used not only for story, but for direction. Like Orion and the Pleiades, it shows that some star patterns are especially good at remaining in human memory because they are visually stable, bright enough to find, and distinct enough not to be confused with the wider field around them. What is striking is that these same bright groups could carry very different meanings in different places. One culture might see a hunter, where another sees warriors. One might see sisters, where another sees birds or seasonal markers. The stars themselves do not tell the story. They only provide the shape sturdy enough for a story to rest on. This is part of what makes the sky such an unusual meeting point between nature and culture. The visible pattern is shared, but the meaning placed onto it can differ widely. And yet some themes return again and again. Human figures appear often. Family groups appear often. Animals appear often. Paths, crossings, tools, and signs also repeat. This is probably not an accident. Human beings tend to remember what feels alive, useful, or emotionally clear. A row of bright stars becomes easier to keep in memory once it becomes a belt, a line of hunters, or a guide across the night. A cluster becomes easier to teach once it becomes sisters or a small flock. The stars become not only visible, but speakable. That mattered in a world where memory was often carried through speech rather than writing. A sky pattern tied to a story could be passed from one person to another with much greater ease than a list of separate lights. A child could be shown the belt of Orion and remember it because it belonged to a figure. A traveler could remember a cluster because it belonged to a season or a tale. In that sense, the stars became memory anchors. They held stories in place, and the stories helped hold the stars in place. So the night sky did not become meaningful all at once. First, the eye grouped its lights. Then those groupings became familiar. Then the familiar shapes gathered names, and the names gathered stories. After that, the sky could be remembered, taught, and used. And once a pattern is remembered well enough, it becomes more than a story overhead. It becomes something dependable, something a person can return to when the time comes to find direction. Some stars became more than beautiful. They became dependable. A person standing in darkness could look upward and find not only wonder, but steadiness. Most of the night sky appears to turn slowly from east to west, rising, climbing, and sinking over the course of the night. But in the north, there is one special point around which that movement seems to organize itself. Near that point sits Polaris, the North Star, a light that appears far more still than the others. It does move, but so little that to ordinary human eyes it feels almost fixed. That stillness made an enormous difference. For people living in the Northern Hemisphere, Polaris offered something rare in a moving sky, a reliable marker. Other stars sweep in wide arcs over the hours. Polaris traces only a very small circle because it sits close to the North Celestial Pole, the point in the sky toward which Earth's northern axis is aimed. So while the rest of the northern sky appears to wheel around that point, Polaris remains in nearly the same place through the night. A person could walk outside at dusk, again at midnight, and again before dawn, and there it would still be, holding roughly the same patch of darkness. It is hard to overstate how reassuring that must have felt in a world without glowing screens, numbered roads, or instant maps. The sky itself was changing constantly, but one light remained calm enough to trust. A person who knew Polaris knew where north was. That did not solve every problem of travel, weather, or landscape, but it offered a stable reference in a wide and otherwise shifting world. Even finding Polaris is a very human kind of skill, because it depends on pattern recognition more than mathematics. The easiest way is to begin with the Big Dipper, one of the most recognizable shapes in the northern sky. The two stars at the outer edge of its bowl, often called the pointer stars, form a line that leads upward toward Polaris. Once seen a few times, the relationship becomes hard to forget. The larger, more obvious shape of the Dipper quietly points toward the smaller and steadier light beyond it. It is one of those satisfying arrangements in the sky where a memorable pattern leads to a useful one. Polaris also carried another practical gift. Its height above the horizon changes with latitude. Near the North Pole, it would appear almost overhead. Farther south, it would sit lower in the sky, and at the equator, it would lie close to the horizon. A traveler did not need to calculate this in modern terms to benefit from it. The simple fact that Polaris rose higher or lower, depending on where a person stood, meant that the sky could help locate one's place on Earth as well as one's direction. What makes this especially elegant is that it remains so visual. The usefulness of Polaris is not hidden behind instruments alone. It begins with a simple experience. One light staying almost still while the others turn around it. A person can stand outside long enough to feel that difference directly. The stars farther from the pole trace wider circles through the night. Some rise and set. Others wheel around without ever dropping below the horizon. But Polaris stays near the center of that motion, like a quiet pin holding a turning map in place. There is also a deeper calm in this kind of sky knowledge. To know Polaris is to know that the night is not only beautiful, but legible. The heavens are not random. They have structure. They can be read. A person lost in open land, or simply standing under a clear winter sky, can look upward and feel that one point of certainty still waiting there. It is not a loud certainty. It does not announce itself. But once learned, it becomes hard to forget. Of course, this gift belongs mainly to the northern half of the world. South of the equator, there is no bright pole star offering the same simple marker. There, people had to learn other patterns and other methods, using the Southern Cross and neighboring stars to find direction in a different way. So the North Star is only one part of a larger human relationship with the sky. Still, it shows something important very clearly. Once people began remembering the stars could begin guiding people in return. And from there, the sky above became useful not only over land, but over open water, where no road, tree, or mountain could help at all. The sky above became a map when the land disappeared. On open water, there are no roads, no fences, no trees, no distant hills to hold direction in place. During the day, the sun can help. But at night, when sea and sky begin to blend into one dark field, the stars become something more than distant lights. They become points of reference, steady enough to remember and clear enough to follow. For sailors long before modern instruments, the night sky was not decoration, it was guidance. In the north, Polaris gave one kind of help. It offered a near fixed point, a reliable sign of north. But over the wider world, people learned many other sky patterns as well. In the southern hemisphere, there is no bright pole star matching Polaris. Instead, travelers learned to use the Southern Cross and nearby stars to judge where south lay. The sky did not offer exactly the same tools everywhere, but it offered enough. What mattered was not that every culture used one single star. What mattered was that the sky could be learned. This is one of the quietest and most impressive parts of human history. People did not simply admire the stars. They remembered them well enough to move by them. A star rising at one point on the horizon meant one direction. A different star setting in another place meant something else. Certain stars appeared during certain seasons. Certain patterns held steady enough through the night to reassure the traveler that the route remained true. In this way, the sky became a working system of orientation spread above the earth. At sea, this mattered especially because water removes so much else. On land, a person may correct their path by noticing a ridge, a river, a stand of trees, or the shape of a valley. On the open ocean, those anchors disappear. The horizon becomes simple and nearly featureless. That simplicity can be beautiful, but it can also be disorienting. Under those conditions, the stars gave structure back to the world. A sailor could lift their eyes and find order again, not below but above. The darkness overhead became a kind of chart. Polynesian navigation offers one of the clearest examples of this. Across enormous stretches of ocean, navigators memorized the rising and setting places of stars and used them as directional guides. This was not casual knowledge. It was disciplined memory, carried through teaching, repetition, and song. A navigator could know which star belonged to which path, and which path led toward a certain island or region of ocean. The sky was not separate from memory, it was woven into it. Some accounts describe this knowledge almost like carrying a map in spoken form, with star paths stored in the body and recalled in sequence. That makes star navigation feel very human. It was never only about numbers or angles. It was also about trust, memory, and calm attention. A person had to know the sky well enough that it became familiar under changing conditions. Clouds might hide part of it. Waves might break concentration. Fatigue might make every light seem less distinct. Still, the trained navigator could return to certain bright forms and rising points, recovering direction from what others might see only as darkness. There is something reassuring in that image. a boat moving over black water. No land in sight. The surface below shifting endlessly. And above it, a set of remembered lights, steady enough to hold the traveler in relation to the world. The stars did not make the ocean smaller, but they made it more readable. They gave a person a way to continue. The same sky could also offer emotional reassurance. A known pattern overhead could calm uncertainty simply by being familiar. That may be one reason star navigation belongs so naturally in this larger story of human life under the night sky. The stars were useful, yes, but they were also companions of a sort. They returned, they repeated, they offered continuity. A sailor could lose sight of land and still not lose all orientation, because the greater pattern above had not vanished. And as people learned to move by stars across land and sea, they also learned another slow truth. The sky did not only guide movement through space, it also guided movement through the year, returning different patterns in different seasons and turning the heavens into a calendar as well as a map. The sky does not only turn each night, it also changes slowly across the year. A person who watches often enough begins to notice that the stars do not return in exactly the same way from one month to the next. A familiar group may rise earlier than it did before. Another may slip lower each evening until it vanishes into the brightness near sunset. Then, after a period of absence, it returns again in the dim light before dawn. That quiet return was one of the oldest signals the sky could give. This is what people now call a heliacal rising. The phrase sounds technical, but the experience behind it is simple. A star or star group disappears for a time because it is too close to the sun's glare to be seen. Then, one morning, just before sunrise, it appears again for the first time in weeks or months. It is not high in the sky, and it does not stay long. Dawn soon washes it away, but its return is noticeable precisely because it has been missing. It is like seeing a familiar face after a long absence and knowing, without needing a clock or a written calendar, that the year has moved forward. That kind of noticing only becomes possible when people watch the sky regularly. A person who looks up once in a while may enjoy the stars, but a person who lives with them night after night begins to sense their rhythm. One bright star is no longer just bright. It belongs to a season. A cluster is no longer just pretty. It returns at a certain point in the year. The sky becomes not only beautiful, but repeatable. And once something repeats reliably enough, human beings begin to use it. This is how stars became natural calendar markers. They did not measure time in the neat, numbered way that modern calendars do. They measured it through return. A certain star appears again before dawn, and that means a season is changing. Another sinks lower in the evening sky, and that means a certain stretch of the year is ending. The stars did not speak in dates. They spoke in reappearance, disappearance, height, and timing. They let people feel the year turning rather than merely count it. There is something very physical about that kind of calendar. It depends on waiting, on remembering, and on comparison. A person has to know that the star was gone. They have to remember roughly where it used to be. Then they have to catch its first return in a narrow window of time, often in the half-light just before sunrise. That creates a different relationship with time than the one most people have now. It is slower, more observant, less numerical. The year is not so much divided into boxes as it is sensed through repeated sky events. This also means the stars were tied closely to anticipation. A familiar star returning to the pre-dawn sky was not just a fact to be noticed. It could carry consequence. It could mean rains were approaching, or flooding, or the right time to plant, harvest, travel, fish, gather, or prepare. The sky was not separate from the practical life below it. It was part of how people kept themselves aligned with the larger cycles around them. And because this knowledge came from repeated watching, it was often grounded in place. The same returning star might mean one thing in a river valley, another on open sea, and something different again on high dry land. The sky was shared, but the use of it was local. People learned which stars mattered most where they lived, and what those returns usually announced. In that way, the heavens became a kind of seasonal memory spread above daily life. It is easy now to think of the stars as distant and untouched by ordinary concerns. But for much of human history, certain stars did not merely mark beauty overhead. Their return suggested action below. A person could wait for a familiar light in the dawn and know that the world was about to ask something different of them. And in some places, that change was very concrete indeed. One returning star could mean a river would soon rise. Another could mean planting time. Another could mean the movement of animals, the timing of travel, or the gathering of food. Some stars did not just mark beauty. They marked flood, planting, travel, and food. Once the sky became regular enough to watch closely and familiar enough to remember, it also became useful in a deeper way. A returning star could mean that water would soon rise. A cluster appearing again could mean it was time to sow fields. A dark shape within the Milky Way could signal that certain animals were nesting, mating, or ready to be gathered. The sky was not separate from survival. It was part of how people stayed aligned with the year. One of the clearest examples is Sirius, the brightest star in the night sky. Each year, after disappearing into the sun's glare for a time, Sirius would reappear in the pre-dawn sky. For the ancient Egyptians, that return mattered greatly. Sirius rising again just before sunrise signaled that the Nile would soon flood. And the flooding of the Nile was not a minor event. It shaped the rhythm of agriculture, water, and life itself. The river's overflow renewed the land, spread rich silt across the valley, and made future planting possible. So when Sirius returned, it did not simply mean that a bright star was back. It meant that the larger world was about to change in a very practical way. The timing was reliable enough that Sirius became part of Egypt's calendar itself. There is something striking in that. A point of light far beyond the earth could become tied, in human experience, to the behavior of a river below. The connection was not magical, it was seasonal. The sky and the land were moving through the same yearly cycle, and careful observers learned to connect one visible sign with another. The heavens did not cause the flood directly, but the return of Sirius gave people advance notice that the familiar season of change was near. That is one of the oldest powers of sky knowledge. It makes time visible before the world below has fully shifted. The Pleiades offered a different kind of signal. This small, tight cluster of stars has drawn human attention almost everywhere because it is easy to notice and easy to remember. In Greece, the Pleiades were tied to the timing of agriculture and the beginning of the sailing season. Their return to the sky became a cue that planting time was near. Hesiod, writing in ancient Greece, linked the first visible return of the seven sisters to the work of sowing fields. In the Andes, the Inca also used the visibility of the Pleiades as part of their farming calendar. The cluster's appearance was not only beautiful, it was useful. It helped people decide when the year had moved into a new phase and when it was time to act. This is what makes stars feel so woven into daily life in older societies. They did not merely decorate the night. They offered cues that could be read and applied. A returning star might influence when seeds entered the ground, when people traveled, when boats set out, or when communities prepared for changing conditions. The sky became a practical memory system held above the earth. In Australia, indigenous sky knowledge shows this in yet another way. The dark dust cloud within the Milky Way, known as the Mu in the sky, was not formed by bright stars alone, but by the shadowed lanes cutting through the galaxy's glow. Its changing appearance across the year could signal times for emu hunting or egg gathering. When the emu appeared to sit on the horizon, it marked part of the emu mating season. Aboriginal astronomers also watched the motions of stars and constellations more broadly to know when certain birds, plants, or seasonal conditions would appear. This is a powerful reminder that sky knowledge was not limited to bright points. Even the darker spaces within the Milky Way could become meaningful if people watched often enough and remembered what they saw. Across these examples, the pattern is the same. Stars became part of survival because they returned with enough reliability to be trusted. Their meanings differed from place to place, but the human act behind them was similar. People watched. They compared one year to another. They noticed which sky events came before floods, planting, migration, nesting, or harvest. Over time, the heavens became part of the working calendar of life below. And yet, even while stars helped mark the year, they also created another impression altogether. They felt steady, fixed, almost permanent. Human lives were short beside them, and the patterns returned so faithfully that the sky could seem nearly unchanging. But that steadiness is only part of the story. The stars look still mostly because their deep emotions unfold on timescales much longer than a single life can easily notice. The stars feel permanent because human lives are brief compared to their visible changes. A person can step outside night after night and find the same familiar shapes waiting overhead. Orion returns. The Pleiades return. The belt stars stand in their neat row. Polaris remains near its place in the north. This makes the sky feel stable, almost fixed, as though it belongs to a slower and steadier kind of existence than the one below. And in many ways, that impression is true. On the scale of a single evening, the sky clearly moves. Stars rise, arc, and sink. Constellations tilt as the hours pass. The whole dome of night seems to turn from east to west. But this movement is not usually felt as change in the stars themselves. It feels more like a rotation of the world around them. The stars keep their patterns while the night carries those patterns across the darkness. A person watching for an hour or two may feel the motion, but they still feel the deeper steadiness underneath it. That nightly turning comes from Earth's rotation. The planet spins, and the sky appears to move because we are moving with it. This is one of the quietest illusions in ordinary life. The ground beneath our feet feels still, yet it is carrying us through space. And the stars seem to circle above because of that motion. In the north, stars wheel around Polaris. Farther south, they rise and set in long arcs. During one night, this movement is obvious enough to notice if a person lingers outdoors, but it is also regular enough to become familiar. The sky is moving, yes, but in a calm and dependable way. There is another rhythm hidden inside that one. A given star does not rise at exactly the same clock time every night. It returns a little earlier, by about 4 minutes each day. Over a month, that small difference becomes significant. A constellation that appeared low in the east at a certain hour may already be much higher by the next month, having risen earlier than before. This is why the seasonal sky changes so gently across the year. It is not that the stars themselves are hurrying anywhere visible to us. It is that Earth is also moving around the sun, and that wider motion changes which part of space the night side of the planet faces. So the sky is always shifting, even when it feels familiar. The changes are simply patient enough that most people experience them as season rather than motion. That patience is part of what makes the stars feel permanent. Human lives are built around days, months, years, and perhaps a few decades of careful memory. Against that scale, the deeper rearrangements of the sky are almost impossible to notice directly. A child may learn Orion in one winter and find it almost unchanged many winters later. A grandparent may show the same star cluster to a grandchild with very little difference in its appearance. The nightly and seasonal motions are easy to feel. The deeper structural changes are not, but they do exist. The stars are not nailed into place. Over very long stretches of time, they move relative to one another. Nearby stars have their own motions through space, though those shifts are usually far too slight for the eye to detect during a normal lifetime. Constellations slowly change shape across many generations, but the drift is so gentle that the sky keeps its familiar outlines for a very long time. Earth's axis also wobbles in a slow cycle over thousands of years, which means even the identity of the North Star changes. Long ago, Polaris did not hold that role. Far in the future, it will not hold it forever. The sky that feels eternal is, in truth, quietly changing all the while. This does not make the stars less steady. It makes their steadiness more interesting. They are not permanent in the strict sense. They are simply changing on timescales much larger than ordinary human life. The sky seems fixed because it moves with extraordinary patience, and that patience can hide something else as well. The stars look still, and they look small. They seem like points pressed lightly into darkness. Yet much of that smallness is only distance wearing the shape of simplicity. The eye sees a tiny light, but the reality behind it is far larger than it appears. The eye sees a point, but distance hides scale. A star can look so small and quiet that it seems almost weightless, as though it were no more than a bright pin resting on a dark surface. But that impression comes from remoteness, not from size. The night sky compresses enormous reality into tiny lights, And because the compression is so complete, it becomes easy to forget what the eye is actually looking at. A star appears as a point because it is unimaginably far away. Even the nearest one beyond the sun is so distant that human vision cannot perceive it as a disk or a sphere. It arrives only as light. The star may be vast, with a diameter far greater than the sun's, but distance smooths all of that into simplicity. The eye receives no visible edge, no surface, no curve, no sense of volume. It receives only brightness. This is one of the strangest things about the night sky. Scale is present everywhere, but almost nowhere visible in the ordinary sense. A person can look up and see a large moon and a tiny star, even though the star may be vastly larger than the moon in every physical way that matters. What the eye measures first is not true size, but apparent size, and apparent size belongs as much to distance as it does to the object itself. The farther something is, the smaller it seems, until eventually even something immense becomes no more than a point. That is why stars feel both intimate and unreachable. They are visible to everyone, yet they remain visually sealed. The eye can receive their light, but not their shape. That light may have crossed years or centuries of space before entering the retina, and after all that travel, it still arrives as something almost impossibly simple. The nearest star system beyond our own includes Proxima Centauri, which lies about 4.24 light years away. That means the light from Proxima takes more than 4 years to reach Earth. Sirius, the brightest star in the night sky, is farther still, about 8.6 light years away. These are among the closer examples. Many stars people see with the naked eye are tens or even hundreds of light years away, with their light beginning its journey long before it reaches any human eye. And yet, despite those distances, they are still present enough to become part of ordinary nights. That is one reason stars feel so unusual in human experience. They are extremely far away, but they do not feel absent. They remain visible, steady, and familiar. This helps explain why the sky can feel full without feeling crowded. The stars are separated by tremendous distances from Earth and from one another, but human vision flattens that depth into a single dome of scattered points. Near and far light seem to rest on the same dark surface. A bright star may appear beside a dimmer one, even if the two are separated by enormous spans of space and have no true closeness at all. The sky gives a beautiful illusion of nearness, and the eye accepts it because the distances involved are too great to sense directly. That flattening is part of the calm of stargazing. The sky does not present itself as a technical diagram. It presents itself as a field. A few brighter lights stand out. Fainter ones recede. Constellations hold their forms. The eye is spared the burden of true scale. If the real distances behind every star could be felt all at once, the sky might become less restful and more overwhelming. Instead, the vastness remains hidden behind stillness. And yet the hidden scale matters, because it changes the meaning of what the eye sees. A tiny point of light is no longer merely tiny, once a person understands that distance is what made it so. The star has not become larger in that moment. It was always large. What changes is the relationship between appearance and reality. The sky begins to feel deeper than vision first suggested. So the stars are not small in the way they seem small. They only appear that way because distance has thinned them down to their light alone. The eye is seeing something enormous in the simplest form possible. And once distance becomes part of the picture, another thought follows naturally. If light takes years to cross that darkness, then every star is arriving late. The sky above is not only distant, it is delayed. The stars do not send themselves to us instantly. They arrive delayed. A person can step outside, look up at a clear sky, and feel as though the stars are simply there, present in the same moment as their own breath, their own thoughts, their own small place on the ground below. But light does not travel infinitely fast. It takes time to cross the distance between a star and the eye. So every star in the night sky is being seen a little late, and sometimes very late. This means that looking at stars is always a quiet meeting between now and then. The idea is simple, even if the distances behind it are enormous. Light moves extremely quickly, but space is very large. So when a star shines, its light begins a journey. Only after that journey ends does it reach Earth. Only then can the eye receive it. The delay may be a few years, or it may be far longer. What matters first is not the exact number, but the strange softness of the fact itself. The sky above is not appearing in real time. It is arriving. Sirius offers a gentle example, because it is familiar and bright. Its light takes about 8.6 years to reach Earth. So when a person looks at Sirius tonight, the light entering their eyes left that star almost 9 years ago. Aldebaran, another well-known star, is much farther, with light that takes around 65 years to arrive. In that case, the star seen on a quiet evening is not the star of this exact moment. It is the star as it was decades earlier, its light delayed by distance and only now completing its path. This changes the feeling of the sky in a very subtle way. The stars are still present, still beautiful, still part of the living night, but they are also carrying time inside their light. A person standing in the present looks upward and receives brightness that began elsewhere in an earlier year. The eye remains in one moment, but what it sees was set in motion in another. The night sky is full of these arrivals. That can sound abstract at first, but the experience itself is not abstract. It is still only a person under a dark sky, seeing points of light. What changes is the meaning resting quietly behind those points. A star is no longer just far away. It is also late. Its light had to survive distance. It had to keep moving through emptiness for years before it could be seen at all. This makes starlight feel different from almost every other kind of light in ordinary life. The light from a lamp feels immediate. Firelight feels immediate. Sunlight feels immediate, even though sunlight also takes time to reach Earth. But starlight carries delay on a scale that the mind can begin to feel as history rather than mere travel. A person is not only seeing light from elsewhere, they are seeing earlier light. And yet, this does not make the stars feel old in a tired way. If anything, it often gives them a deeper kind of stillness. The sky becomes less like a ceiling of lights and more like a field of messages in transit, each one arriving from a different depth of time. Some have traveled only a handful of years. Others began far earlier. The eye cannot tell the difference just by looking. A bright star and a dim one may both seem equally present, even if one is sending very recent light and the other is sending something much older. That hidden unevenness gives the sky a kind of layered time. Different stars are not only at different distances, they are arriving from different moments. A person looking upward sees a single night, but within that single night are many separate journeys ending together. There is something calming about that once it settles in. The stars do not rush to reach us. They arrive when they arrive. Their light crosses darkness patiently, and the eye meets it without needing to do anything except remain open. No human effort speeds the journey. No worry slows it. The sky continues sending its light across years of emptiness, and on some quiet night, that light finally reaches a field, a rooftop, a hillside, or the window of someone unable to sleep. So the stars are not only distant, they are temporal. They make time visible in a way that feels almost gentle. And if light can take years to cross the distance between one star and one eye, then the deeper structure of the sky must be changing on timescales far slower than a single human life can easily notice. What feels fixed above us is often only moving with extraordinary patience. The sky seems eternal because its deeper changes are patient. A person can live an entire life under familiar constellations and never feel that the larger structure above has shifted very much at all. Orion returns each winter. The Pleiades gather in their small, bright cluster. Polaris holds its place in the north. The stars rise and set, seasons turn, and the general shape of the sky feels steady enough to trust. That is one reason the heavens have so often felt permanent to human beings. Their motions are real, but many of them unfold so slowly that ordinary life passes beneath them almost untouched. And yet the night sky is not frozen. Even within a single lifetime, a person can notice the nightly turning of the stars and the seasonal return of familiar constellations. But beyond those rhythms lies a slower kind of motion, one that asks for centuries, millennia, and longer stretches of time before it becomes obvious. The sky changes, just not at the speed human eyes are built to track easily. What feels like stillness is often motion spread across such a long span that it becomes almost invisible. One of the clearest examples is the slow wobble of Earth's axis. Earth does not point in exactly the same direction forever. Like a spinning top that wobbles as it turns, our planet's axis traces a slow circle through space over about 26,000 years. This means the point in the sky around which the stars seem to rotate also drifts gradually. Because of that, the identity of the North Star changes across long ages. Polaris holds that role now, but it has not always done so, and it will not do so forever. About 14,000 years ago, the bright star Vega stood much closer to the north celestial pole, and in about 12,000 years it will return to that position again. That is a wonderfully quiet kind of change. No one steps outside and sees Polaris leap away from its place. No child watches the pole of the sky visibly move during a single winter. The drift is far too slow for that. But generation by generation, age by age, the heavens do rearrange their emphasis. A star that seems central in one era may be only one bright light among many in another. The structure remains, but the details shift with extraordinary patience. The constellations themselves also change, though not in a way people usually notice from year to year. Stars are not fixed beads attached to a solid shell. They are moving through space on their own paths. Those motions are called proper motion, and over very long periods they slowly alter the shapes people know so well. A hunter outlined by one arrangement of stars will not hold exactly the same proportions forever. A familiar pattern may widen, tilt, or thin out across thousands of years. But because those changes are so slow, human memory usually experiences constellations as stable. The stars keep their forms long enough to become part of culture, story, and daily recognition before their deeper drift becomes significant. This means that the sky ancient people saw was both the same as ours and not quite the same. They recognized many of the same bright star groups. They watched the same broad Milky Way cross the darkness. They could follow many of the same seasonal returns. And yet the exact long-term geometry of the heavens was not perfectly identical. Polaris was not always the same guide. Constellations were not always arranged with precisely the same spacing they show now. The sky carries continuity, but not immobility. It lives on a timescale larger than ordinary history. There is something calming in that thought. The stars are not static, but neither are they hurried. They change without urgency. They shift so slowly that whole civilizations can rise and fall beneath them, while the larger patterns remain almost unchanged to the eye. The heavens do not resist time. They simply experience it differently. And that returns the subject to a very human contrast. A single life is short. A season feels substantial. A decade feels long. But the sky above moves according to measures that make even centuries feel brief. What looks still is often only moving at a scale beyond immediate perception. That is why the stars can feel eternal while still remaining alive, active, and in motion. So after deep time and patient change, the simplest experience of the sky remains what it has always been. One ordinary night, one person looking up, and a field of lights that appears calm enough to rest beneath. The stars may be shifting across ages, but in any given evening they still return as something familiar, something steady, something quietly overhead. After all the history and meaning, the night still returns to simple watching. A person lies back beneath a dark sky, and the first feeling is often not explanation, but space. The ground stays close. The air cools around the skin. The world nearby grows quieter and less detailed. And above, the sky opens into something broad enough that the eye does not quite know where to settle first. The Milky Way is often the clearest sign that the sky has become truly dark. It does not usually look the way photographs make it look. It is not bright blue or sharply outlined or packed with obvious color. To the eye, it is softer than that. It appears as a broad, dim river of light, a pale band stretching across the darkness, sometimes thin and faint, sometimes thicker and more textured, depending on the season and the clarity of the air. It feels less like an object and more like a presence, as though the sky itself has gathered into a long, quiet current overhead. If a person waits with it, that band often begins to change. Not because it is moving quickly, but because patience reveals more of it. The eye starts to separate uneven brightness from deeper shadow. Some parts of the Milky Way seem richer, fuller, almost misted with starlight. Other parts seem cut through by long, dark lanes. Those lanes are among the strangest things visible under a truly dark sky. At first, they can look like emptiness, but slowly, they begin to feel shaped, as though darkness itself has been laid across the brighter river in branching strips. Under strong city light, they usually vanish. Under deeper darkness, they return. The stars around the Milky Way hold stillness in a different way. Some remain bright and steady enough to anchor the eye. Others are dimmer, less immediate, noticed only after a longer look. The whole sky becomes fuller by degrees. A star near the edge of vision sharpens. Another appears just above it. A patch that seemed blank begins to show finer grain. Even after all the earlier sections of this journey, the sky still asks for the same simple thing. It asked from human beings long ago, to stay with it long enough for it to unfold. Now and then, something interrupts that stillness briefly. A meteor may cross overhead in a quick silver line, there and gone in a moment. It does not usually last long enough for the eye to study it. It flashes, vanishes, and leaves behind a brief widening of attention. The sky seems even larger afterward, as though that short streak has reminded the eye that this darkness is not empty, only quiet. During meteor showers, there may be more of them, but even on an ordinary night, the occasional sudden line can appear without warning. Other moving lights behave very differently. A satellite does not streak, it glides. At first, it may look like a star that has somehow decided to move, crossing the sky at a steady pace without twinkling much, without flaring, without hurry. It can be oddly calming to watch because the motion is so even. A meteor belongs to a moment. A satellite belongs to duration. It keeps going, patient and smooth, until it fades into Earth's shadow, or slips too far toward the horizon to follow easily. What makes all of this feel so restful is that none of it demands a quick response. The sky is full, but not crowded. It offers change, but slowly. Even its briefest events happen inside a much larger stillness. A person lying under a dark sky is not trying to solve anything. They are simply letting the eye move, stop, drift, return. The Milky Way overhead, dark lanes within it, a faint satellite crossing, a meteor once in a while. The slow, bright persistence of familiar stars. And perhaps that is part of what has always made the night sky feel so different from the lit world below. It gives the eye something to do without pressing it. It holds attention without straining it. It is rich but quiet. And that is precisely what so many people no longer get to see. The sky is still capable of all this fullness. It is still there. But in much of the modern world, brightness from below rises high enough to cover over the softer lights above. The night did not grow emptier overhead. It grew brighter below. That is one of the strangest changes in modern human life. The stars are still above the cities, the suburbs, the roads, the shopping centers, and the apartment towers. The Milky Way still crosses the sky. The fainter stars still fill the darker spaces between the brighter ones. But much of that fullness no longer reaches the eye, because light rising from the ground has begun to cover it over. This is what light pollution really is. It is not the destruction of the stars themselves. It is the loss of contrast that lets human vision detect them. Artificial light spills upward, scatters through the air, and creates a pale glow over towns and cities. That glow makes the night sky brighter than it should be, which means the dimmer stars are the first to disappear. Then the Milky Way fades. Then the wider texture of the sky goes with it. In many places, only the brightest stars and planets remain, scattered thinly above a washed-out background. For someone who has only known city skies, this thinner version of night can feel normal. A handful of stars, perhaps a bright planet, maybe one familiar shape half visible through haze. It may not feel like a loss because there is nothing beside it for comparison. But move into a truly dark place and the difference becomes immediate. The sky deepens. More stars appear at once. The Milky Way returns as a broad, pale band. Dark lanes begin to show within it. The whole night regains layers. What seemed empty was never empty at all. It was hidden. This contrast between city sky and dark sky is one of the sharpest visual differences modern people can still experience. In bright urban areas, a person may see only a small fraction of the stars available to human vision. In protected dark sky places, thousands return. The change can feel almost unbelievable, not because the dark sky view is exaggerated, but because the brighter world below has quietly taught so many people to expect less from the heavens. And what disappears visually may not be the only thing that is lost. The same artificial brightness that hides the stars also changes the body's relationship with night. The natural light-dark cycle helps guide when the brain releases melatonin and when the body begins preparing for sleep. Light at night can interrupt that pattern, keeping the brain in a more wakeful mode for longer than darkness would have done on its own. So when the modern world brightens the sky, it is not only changing what people see, it is also changing how night feels physiologically. This makes light pollution more than an astronomy issue. It becomes part of a wider human shift away from darkness itself. Many people no longer experience a truly dark evening unless they leave the built environment behind. The night remains present in name, but its older visual and bodily cues are softened, delayed, or erased. The stars fade, and the body receives weaker signals that rest has begun. The atmosphere of evening becomes thinner. Because of that, efforts to protect dark skies are about more than telescopes or scientific observation. They are also about recovering a human experience that was once ordinary. Dark sky parks, reserves, and communities do not create some rare luxury. They preserve the possibility of seeing what earlier humans would have known as a normal night. A sky full of stars, a visible Milky Way, and a darkness deep enough to let both the eye and the body settle into a more natural relation with evening. There is something quietly moving in that idea. The stars are still available. The sky has not closed. In some places, with a little distance from the electric glow, it opens again almost immediately. And when it does, people often feel more than visual surprise. They feel relief, calm, or a kind of return they did not know they were missing. What is lost then may not be only the sight of the stars themselves. It may also be part of the emotional and bodily experience that once came with living beneath a darker night. And that helps explain why even a brief encounter with a truly starry sky can seem to quiet people so quickly and so deeply. Something about the starry sky seems to quiet people quickly and without effort. A person may step outside carrying the weight of the day, the leftover pressure of work, unfinished thoughts, small worries still moving in circles, And then, after only a short time under a dark sky, something begins to loosen. The stars do not solve anything. They do not answer questions directly. And yet they often seem to change the tone of the mind almost at once. Part of this may come from the sheer scale of what the eye is meeting. A starry sky feels large in a way that no ordinary room, road, or screen can feel. It stretches beyond the edge of any immediate task. It offers distance without asking the viewer to chase it. Modern psychology research has found that starry sky imagery can produce strong feelings of awe very quickly, sometimes within only a few minutes. People report a sense of vastness, connectedness, softened self-focus, and even a slight change in how time feels, as if the ordinary pace of thought has slowed or widened. That word awe can sound dramatic, but in this context, it does not have to mean intensity. It can be gentle. It can mean the feeling that the self has become smaller in a relieving way, not a frightening one. Under a wide sky, a person may stop feeling like the whole world is narrowed down to one decision, one email, one deadline, one conversation, one problem. The stars do not erase life. They simply place it inside a wider frame. And that wider frame often brings calm with it. Researchers also use a quieter phrase for part of this effect: soft fascination. The idea is simple. Some environments hold attention without demanding too much from it. They occupy the eye and mind gently rather than forcefully. A starry sky is full of visual interest, but it does not shout. It gives the eye small points to rest on, faint structures to follow, darkness to move through, and occasional motion to notice. It keeps attention engaged but not strained. That is a very different experience from the bright, fast, task-heavy kinds of attention modern life often requires. This may be one reason people often describe stargazing as both absorbing and restful at the same time. The sky is not empty, so the mind does not drift into the same kind of restless circling that can happen in total boredom. But it is not crowded either, so the mind does not become overloaded. Instead, it enters a middle state. There is enough to notice, but not too much. Enough structure to hold attention, but not enough pressure to harden it. The stars are especially good at this because they are familiar without being repetitive. Human beings have looked at them for so long that the eye seems to know what to do with them almost instinctively. One bright star catches attention, then a cluster, then the Milky Way, then a darker lane across it, then a small pause, then another star at the edge of vision. The sky gives attention somewhere to go, but it does not force where it must land next. That looseness matters, and it may help explain why the emotional response to stars often feels different from the response to other grand sights. Mountains are large, but they are solid and close. The ocean is wide, but it moves with stronger visible force. The night sky is vast in a quieter way. It remains distant, untouchable, stable enough to feel safe, yet large enough to change perspective. A person can lie still beneath it and feel both held and widened at once. Some studies also suggest that people find starry skies more pleasant and more mentally restorative than urban scenes. That fits something many people already sense for themselves. A bright city can keep the mind busy, alert, and divided. A dark sky often does the opposite. It gathers attention rather than scattering it. it lowers the need to decide what matters next. It does not remove thought entirely, but it often softens thought into something less urgent. So the calming effect of stars may not come from one single cause. It may come from several things at once: darkness, distance, vastness, gentle visual structure, reduced self-focus, and the old familiarity of looking upward into something larger than the day's concerns. The result is often immediate enough to feel almost ancient, as though the human nervous system already knows this kind of scene. And once the sky becomes calming in that way, it rarely remains only visual. Human beings tend to keep looking until perception turns into meaning, and meaning is where stars have always gathered some of their deepest power. Once the sky becomes familiar, it also becomes symbolic. The stars begin as light, then become patterns, then guides, then markers of season and time. But human attention rarely stops there. Anything watched often enough, trusted often enough, and remembered often enough begins to gather meaning around itself. The stars have done this for so long that it is almost impossible to separate what they are from what they have come to mean to people. One reason is simple repetition. The stars return. Even though the sky shifts across the seasons, certain bright groups come back year after year. Polaris remains near the north. The Pleiades gather again in their small cluster. Orion reappears in its season. That reliability makes stars feel different from many other parts of life. Weather changes quickly. Rivers flood and fall, trees lose leaves, roads disappear, people come and go. But the stars keep returning in ways that can be trusted, and what returns reliably tends to become a symbol of steadiness. That helps explain why stars so often came to represent guidance. The North Star is the clearest example because it offered literal direction, holding near the same place while the rest of the northern sky turned around it. It was useful first. Only after that did it become meaningful in a broader sense. A light that can guide the traveler through darkness easily becomes a symbol of constancy, hope, and orientation in life more generally. The practical and the symbolic grew together. Polaris did not become important because people wanted a metaphor. It became a metaphor because it was already important. The Pleiades offer a different kind of meaning. They were not only used to mark seasons or support farming calendars. Because they appear as a compact and striking group, they often became symbols of family, sisters, or closeness across different cultures. The same cluster that helped mark a turning point in the agricultural year could also carry emotional and social meaning. It could be remembered not only as a sky event, but as a relationship held in light. That overlap between practical use and human feeling is one of the oldest patterns in the way people treated the stars. Stars also became symbols of ancestors, destiny, and the larger order of life because they sit at a strange distance from ordinary human events. They are visible but unreachable, present but untouched, always overhead but never part of the shifting ground. That makes them especially easy to place on the border between the familiar and the mysterious. A person can know the stars closely enough to name them and navigate by them, while still feeling that they belong to a wider reality, not fully under human control. That combination gives them unusual symbolic power. It is also striking how often distant cultures arrived at similar kinds of meaning. Bright star groups repeatedly became figures, families, guides, or markers of important change. This does not mean everyone told the same story. They did not. But the underlying tendencies appear again and again. Human beings seem drawn to use the stars for continuity, direction, memory, and relationship. A sky that returns regularly becomes a natural place to store these things. It holds what lasts. Part of this may come from repeated attention itself. When people look at something once, they may enjoy it. When they look at it across years, in different seasons, in different moods, while traveling, farming, resting, waiting, grieving, celebrating, or telling stories to children, the object begins to deepen. It stops being only seen and starts being lived with. Meaning grows out of that kind of attention. The stars gathered symbolism, not because humans arbitrarily decorated them with ideas, but because humans stayed in relationship with them long enough for those ideas to accumulate. That is why stars can still feel meaningful even to people who know the science behind them. Knowing that Polaris is not eternally fixed does not erase its symbolic role. Knowing that the Pleiades are a real star cluster does not empty them of their long human history as a group of sisters or companions. Knowledge does not necessarily flatten meaning. Sometimes it adds another layer to it. The stars can be physical lights, useful markers, and human symbols all at once. So by the time people looked up and saw guidance, hope, destiny, constancy, or ancestry in the stars, they were not inventing meaning from nothing. They were extending patterns already built through centuries of watching. The sky became symbolic because it had already become familiar. And that familiarity may be one of the deepest continuities of all. Across thousands of years, beneath changing languages, cities, tools, and beliefs, people kept lifting their eyes to many of the same lights overhead. The stars above any one person are older than memory and more widely shared than almost anything else. A roof in a modern city, a quiet field beyond the edge of town, a desert camp, a ship crossing dark water, a child lying awake beside an open window, an elder stepping outside into the cold for one last look before sleep. So many different lives, so many different centuries, and yet above them, many of the same lights. That may be one of the gentlest truths in the whole sky. Human beings have changed almost everything around themselves. We have changed where we live, how we move, how we eat, how we work, how we measure time, and how brightly we light the night. Entire civilizations have risen, altered the shape of the land beneath them, and disappeared. Languages have changed. Borders have changed. Beliefs have changed. Yet the act of looking upward into darkness and finding familiar stars is one of the few human experiences that still links the present to people very far away in time. A person living thousands of years ago could not have imagined most of the modern world, and a modern person often cannot easily imagine the daily conditions of ancient life. But both could know what it means for the eyes to adjust slowly to darkness. Both could know the first bright star of evening. Both could notice a cluster like the Pleiades returning in its season. Both could feel the difference between a moonless sky and a moonlit one. Both could watch Orion climb into view, or lift their attention toward a sky that seemed larger than the concerns of any single day. That continuity matters because it is not only visual, it is emotional, bodily, and quiet. The stars are not just something human beings have studied. They are something human beings have lived with. The body has always known the fading of evening. The eyes have always known the patience required for darkness. The mind has always responded to distance, stillness, and repetition. Long before anyone understood the chemistry of melatonin, the mechanics of vision, or the scale of stellar distance, people still knew what the sky felt like when night truly arrived. And that feeling remains available now, even after everything else that has changed. A person today may know that stars are far larger than they appear, that their light takes years to arrive, that Polaris will not always remain the North Star, and that constellations themselves drift slowly across great stretches of time. All of that is true. But the deeper human experience has not been erased by knowledge. If anything, it becomes richer. The stars remain quiet enough for rest, vast enough for awe, dependable enough for memory, and distant enough to keep their calm. Old light still arrives. Darkness still asks the body to soften. The night still becomes larger when the eyes are willing to stay with it. There is also something comforting in the fact that the stars do not depend on being fully understood in order to matter. A person does not need to know exact distances, names, or celestial mechanics to feel the sky widening overhead. They do not need to identify every bright group to feel that familiar slowing of thought under a dark horizon. Much of the power of the stars has always lived in direct experience. In the simple act of seeing, in the way attention loosens and extends, in the sense that the world is larger than the room, the road, the task, or the worry that seemed so important a little earlier. So perhaps the stars endure in human life not only because they are beautiful, but because they continue offering the same quiet gifts they always have. Orientation, repetition, perspective, patience, a place for thought to soften, a place for story to begin, a reminder that night is not empty, but filled with light too far away to hurry and steady enough to keep returning. And as this journey settles, that may be enough to leave resting in the mind. Not the need to hold every fact, or remember every section, or follow every point all the way to the end. Only the sense that above countless human lives, across sleep and waking, through changing seasons and changing centuries, the stars have remained one of the oldest common experiences of being here at all. They are still there now, whether seen clearly or only imagined beyond the glow. Still arriving, still waiting above the darkening world. And whether the listener remains awake for another few minutes or drifts gently into sleep, the sky does not mind. It keeps its patient watch overhead, just as it has for so many others before. So the night can stay wide now. The thoughts can grow lighter. The day can loosen its hold. And somewhere above, beyond roofs and clouds and distance and time, the stars remain where they have always been. Quiet enough to follow, quiet enough to wonder at, and quiet enough to rest beneath.